Hello everyone, this is Manikumar Vuppala of CSITA section studying in Institute of Aeronautical. Today's my Tech Talk topic in Principles of IoT is IoT and the Environment. Introduction to IoT Internet of Things. IoT refers to the network of interconnected devices that collect, exchange, and act on data using embedded sensors, software, and other technologies. These devices can be anything from smart home gadgets to industrial machines and environmental sensors. IoT is transforming how we interact with the world, especially in addressing environmental challenge through smart and automated solutions. Importance of environmental monitoring. Environmental issues like climate change, air and water pollution, deforestation, and biodiversity loss are going globally concerns. Accurate real-time data is essential for effective response and prevention strategies. Traditional methods of environmental monitoring are often manual, expensive, and limited in scale. IoT enables 24 by 7 remote monitoring, providing large-scale, reliable, real-time insights to mitigate risk and enhance sustainability. Key applications of IoT in the environment. First one, air quality monitoring. Second one, water quality monitoring and leak detection. Third one is forest fire detection. And fourth one is smart waste management. Then fifth one is wildlife tracking. Sixth one is smart agriculture. Air quality monitoring. IoT sensors are placed across cities and industrial zones to detect pollutants such as particulate matters PM2.5 and PM10 and carbon monoxide CO, nitrogen dioxide NO2, sulfur dioxide SO2. Data is sent to cloud platforms for visualization and alerts used by governments and organizations to enforce environmental regulation and protect public health. Example, Delhi's air quality monitoring network using IoT enabled AQI air quality index displays. Water quality and leak detection. Here, IoT devices help monitor water quality like pH, turbidity, contamination, and detect pipe leaks in real time. Like in any wall, if there is a water leakage by pipe broken, then we can detect it by some sensor machines. It can so that we can detect the pipe leakage place and measure water levels in dams, rivers, and tanks. Track usage in households and industries to avoid wastage, prevents contamination and reduces freshwater loss. Example, smart irrigation systems in agriculture using soil for farming. Forest fire detection. Forest fire risk can be significantly reduced using IoT, Internet of Things, like sensors detect temperatures, smoke, gas, gas levels, and humidity. It means the sensors will detect temperature around the forest. Like if there is fire, the temperature will be high, and it will automatically say, the sensor sends the sends the notice or emergency alert to the emergency systems. And it can also detect smoke and gas levels and humidity. Data in sent to emergency systems or mobile alerts. Drones and satellite integrated IoT devices give a bird's eye view. Example, California's fire-prone zones use real-time fire detection systems based on IoT networks. Smart waste management. IoT enable smart bins, monitor fills level and send alert to waste collection services. Waste collection routes can be optimized using real-time data saving fuel and time benefits. Avoid bin overflow and bad odor, increases recycling efficiency, reduces carbon emission from garbage trucks. Example, Pune smart cities waste collection systems using GPS and fill line sensors. Wildlife tracking and conservation. Animals in protected areas are tagged with IoT based GPS collars, tracks their location, migration, and behavior patterns, helps prevent poaching and allowing timely responses to unusual movements. Example, living safe zones. Example, tracking snow leopards in Himalayas using IoT collars and drones. Smart agriculture. IoT helps farmers monitor soil moisture, temperature and humidity, crop health. Enables precision farming, giving the right amount of water, fertilizer at a right time. Benefits: saving water, increases yield, reduces environmental damage for overuse of chemicals. Example, IoT based drip irrigation systems in farming. Benefits of IoT for environmental protection: real time data, fast detection of changes or anomalies. Automation reduces need for human intervention. Resource efficiency, less wastage of water, energy and fuel. Early warning systems prevents disasters like floods or fires. Data driven policies, smart government decision making and good environment awareness. Challenges of using IoT in environmental applications: high initial cost of sensors, networks and maintenance, data privacy and risk of cyber attacks on IoT networks, lack of infrastructure in remote or rural areas, energy consumption of IoT devices may offset environmental benefits in not not optimized. Data overload requires proper fertilization and interpretation of large data sets. Future scope and trends: integration of IoT with AI, artificial intelligence, and big data for better predictions and automated decisions. Uses solar powered IoT devices to make systems energy efficient. Expansion of edge computing to analyze data locally in real time. Vendor adoption in climate action, urban planning, and disaster management. Conclusion: IoT is a powerful tool for building a sustainable and environmentally responsible future. From water monitoring to wildlife conservation and smart farming, its applications are vast. With the right strategies, and innovations, IoT can help us tackle major environmental challenges effectively. Thank you everyone for this opportunity.